Hello everyone. In this video, we will write our basic architecture and code for the product service. We have already created the product service class. Now we will add its core fields, constructor, and getAllProducts method. Then we will explain each line in plain language. First, let's write the code. Great, that's our snippet. Now let's unpack it line by line. Field declaration. Private read-only IUnitOfWork_unit of work. What it does, defines a private field named _UOW of type IUnitOfWork, marked read-only. Why it matters. This lets the service call all repository operations through a single, shared unit of work instance, and read-only ensures we only assign it once in the constructor. Field declaration. Private string _www root path. What it does, declares a private string field named www root path. Why it matters, we'll use this later to store the web root path, so our service can locate and save image files under the wroot folder. Constructor defines a public constructor that takes one parameter, an IUnitOfWork instance named UOW, and assigns it to the private _UOW field. Why it matters, enables dependency injection to supply our product service with the data access layer it needs, without the service creating its own dependencies. getAllProducts method. What it does, declares a public method named getAllProducts, returning a collection of product entities. Calls _UOW product.getAll to fetch every product from the database. Stores the result in product list and returns it. Provides a single, reusable method to retrieve all products. Keeps controller and view code clean by encapsulating data retrieval logic in the service layer. To summarize, we defined our service's private fields for data access and file path management. We set up the constructor for dependency injection of the unit of work using UOW and _UOW shorthand. We implemented getAllProducts to fetch all products via our repository. With these foundations in place, product service is ready for more advanced methods, like upsert and delete with file handling, which we'll tackle in the next video. See you there. Hello. Next up in product service, we'll implement the getProductVM method to prepare our view model for the upsert form, combining a fresh or existing product and a drop-down list of categories. Let's write the code. Our method is ready. Now let's break down what each part does. Method signature. Public product VM getProductVM nullable int ID. Declares a public method returning a product VM and taking an optional integer ID. Initializing the view model. Product equals new product starts with an empty product object for the create case. Category list calls _UOW category.getAll to fetch all categories. Uses select to map each category into a select list item with text set to the category name and value to its ID string. We builds the drop-down list so the upsert form can show all available categories. Loading existing product, edit case. Checks if an ID was provided and is positive. If so, replaces the empty product with the one fetched from the database. For editing, we pre-fill the form with the existing product's data. Returning the view model. Return product VM. Sends the fully prepared product VM back to the controller, which passes it into the upsert view. Y ensures the view always has both a product object and a category list to render the form correctly. To summarize, we created getProductVM to serve both create and edit scenarios. We populated the category drop-down by mapping categories into select list item objects. We conditionally loaded an existing product when an ID was provided. With this method in place, our upsert view has everything it needs to render a category selector and pre-fill product fields. In the next video, we'll scaffold the upsert.cshtml view itself and wire up the image preview and drop-down. See you there. Hello. Let's implement the upsert product method in product service, handling both create, update, and image uploads. First, we'll write the code, then walk through it step by step in a smooth, narrative style. Firstly, we check whether the user has provided a file. If file is not null, we generate a unique file name using a GID, determine our upload folder under WooRoot img of products, and extract the file's extension so it stays in the correct format. Next, if the product already had an image, we build its old file path and delete it from disk. This keeps our storage clean and prevents orphaned files. After that, we open a file stream in create mode at the target path and copy the uploaded file into it. Once that's done, we update product VM, product, picture with the relative URL, so our views know where to find the new image. Then, we decide whether this is a new product or an update by checking product.id. If the ID is 0 or less, we call add. Otherwise, we call update on our product repository. Finally, we invoke _UOW, save to commit all changes, both the new or updated product record and any file path updates, to the database in one atomic operation. Why upsert instead of separate create edit? In our category service and order service, we wrote separate methods for create and edit. Here, though, we chose a single upsert method to handle both scenarios. The advantages are less duplicate code. We avoid writing two nearly identical methods and views. Simpler learning curve. Once you understand one flow, you master both create and edit. Centralized logic. All validation, file handling, and save logic live in one place. For learning purposes, practicing an upsert pattern helps you grasp how to consolidate operations and make your code drier. Don't repeat yourself. Setup. Creating the image folder. Ensure that the WooRoot img or products directory exists in your project. Here's how. In Solution Explorer, expand WooRoot. Right-click WooRoot. Choose Add New Folder and name it img. Right-click img, choose Add New Folder and name it Products. This folder will store all product images, matching our upload path logic. With Upsert product now fully implemented and our folders in place, in the next video we'll write and explain the delete method in product service. Stay tuned. See you then. Hello. In this video, we'll add the delete method to our product service, allowing us to remove products cleanly. First, we'll write the code, then we'll walk through each part in a narrative style. First, we go to the product repository on our unit of work and call getFirstOrDefault with a filter that picks the record whose ID matches the provided ID, thereby retrieving that specific product entity from the database. Next, we pass that product into _UOW product remove. This queues an instruction to delete the entity from our dataset. Finally, we call _UOW save to commit the deletion. Under the hood, Entity Framework generates a delete SQL command and executes it against the database. And that's all there is to our delete method. You now have a simple, reliable way to remove a product using the unit of work pattern and repository. Thanks for watching. Hello everyone. In this video, we're going to flesh out our previously empty order service class by adding its first method and walking through each step. Let's start by writing the code. Now let's break down what each part does. First, we set up our unit of work field by saying a private read-only field of type our unit of work named UOW. This holds the unit of work instance and, thanks to read-only, can only be set in the constructor. Next, we prepare a place for our view model with a public property of type OrderVM, also named OrderVM. This will carry both summary and detailed data for orders when needed. Then, we write the constructor like this. The order service constructor takes one parameter, an unit of work called UOW, and inside the constructor we assign that parameter to our private UOW field. We inject the unit of work so the service can access all our repositories. Now comes our actual data retrieval method, getAll. We define a public method named getAll that returns an IEnumerable of order product. Inside getAll, we call our unit of work's order product repository and request all items where order status is not delivered. We store the result in a variable called orderList, then return orderList. Inside getAll, we call our unit of work's order product repository and ask for all items where the order status is not delivered. What did we achieve here? We made sure order service can talk to all repositories by injecting UOW. We prepared a view model placeholder with OrderVM. We implemented getAll to fetch only those orders that aren't marked delivered. With this in place, order service now supports its core read operation. In the next video, we'll add methods for creating, updating, and deleting orders using the same approach. See you in the next video. Hello everyone. In this video, we're going to extend our order service by adding the details method, which will load both the order header and its related line items in one go. Let's start by writing the code. Great, that's our method. Now let's break down what each part does. First, we define a public method named details that returns an OrderVM and takes a single integer parameter, ID. Next, inside the method, we create a new OrderVM object by initializing its two properties. Order product is set by calling the order product repository's getFirstOrDefault method, filtering for records whose ID matches the provided ID, and including the related app user data. This fetches the main order record along with its related user details. Order details is set by calling the order details repository's getAll method, filtering for records whose order product ID matches the provided ID, and including the related product data. This retrieves all line items for that order, each populated with its product information. Then, we assign this newly initialized OrderVM to our service's OrderVM property and return it to the caller. What did we achieve here? We created a single method that packages both order header and line details into one OrderVM. We leveraged our unit of works repositories with eager loading to fetch related data in one call. Controllers can now simply call details with an ID and receive a fully populated view model. With details in place, order service now offers a complete read operation for both summary and detailed data. Hello. In this video, we're going to implement the delivered method in our order service, which will mark an order as delivered and save that change. Let's start by writing the code. Now let's break down what each part does. First, we declare a public method named delivered that returns an order VM and takes an order VM object as its parameter. Next, inside the method, we retrieve the existing order record by calling the order product repository's getFirstOrderDefault method, filtering for records whose ID matches orderVM.orderProduct.id. Then, we update the retrieved order status by setting orderProduct.orderStatus to the string delivered. After that, we call the order product repository's update method to mark the record for update, then call save on our unit of work to persist the change to the database. Finally, we return the original order VM back to the caller, now representing a delivered order. What did we achieve here? We added a method to change an order's status to delivered. We fetched the correct order record using our unit of works repository. We applied the status change, updated the repository, and saved it in one cohesive operation. With delivered in place, order service can now mark orders as delivered. In the next video, we'll continue by adding any remaining operations and wrapping up our service. See you next time. Hello everyone. Let's dive deeper into our cancel order method in order service, explaining not only what each line does, but why it's there and how it affects our application. Let's start by writing the code. Great, our code is in place. Now let's break down what each part does. First, we define a public method named cancelOrder that returns an order VM and takes an order VM object as its parameter. Why it matters? Any controller or consumer can call cancelOrder, pass in the current order view model, and receive back the same view model, now updated to show the order is cancelled. Next, we retrieve the existing order record by calling the order product repository's getFirstOrderDefault method, filtering for the record whose ID matches orderVM.orderProduct.id. What this does, it fetches the precise database entity for the order the user is viewing. Why it matters? Without loading the real entity, we couldn't modify its status. This step ensures we work on the actual data stored in our database. Then, we update that order's status by setting orderProduct.orderStatus to the string cancel. What this does, it changes the in-memory object's status property to reflect cancelled. Why it matters? Changing this property signals to everyone, both the application and the end user, that the order is no longer active and should be treated accordingly. After that, we call the order product repository's update method to queue the change, and then call save on our unit of work to persist it to the database. Update tells Entity Framework, track this modified object and prepare an update SQL command. Save executes that SQL command against the database so the status change is permanent. Why it matters? Without these calls, our in-memory change would never reach the database, meaning the cancellation would not actually take effect. Finally, we return the original order VM, now reflecting the cancel status. What this does, the updated view model flows back to the controller, which can then render a confirmation view or redirect the user, now showing cancelled in the UI. Why it matters? By returning the same view model, we keep the flow simple and ensure the UI displays the latest data immediately after the operation. To summarize, we locate and load the actual order entity from the database. We change its status property in memory to cancel. We instruct our ORM to update that record and then commit it. We return the updated view model so the user sees the cancellation immediately. With cancel order fully explained, order service can now handle order cancellations in a way that's transparent, reliable, and instantly reflected in our application's interface. See you in the next video. Hello. In this video, we're going to flesh out our order service by adding the update order details method, which updates customer information on an existing order. Let's start by writing the code. Altered, our code is in place. Now let's break down what each part does. First, we define a public method named updateOrderDetails that returns an order VM and takes an order VM object as its parameter. Why it matters? This signature allows any caller to pass in the view model with updated customer fields and get the same model back, reflecting those changes. Next, we retrieve the existing order record by calling the order product repository's getFirstOrderFault method, filtering for the record whose ID matches orderVM.orderProduct.id. What this does, loads the single order entity we want to modify. Why it matters, ensures we update the correct record and work with the latest data. Then, we copy each field from the incoming view model to the loaded entity. What this does, updates the in-memory entity's properties with the new values provided by the user. Why it matters, reflects the customer's new address, postal code, phone number, and name before saving. After that, we call _UOW.orderProduct, update order product, to queue the change and then _UOW, save to persist it to the database. Update marks the entity as modified, preparing an SQL update. Save executes the update against the database. Why it matters, commits the user's changes so they become permanent. Finally, we return the original order VM, now containing the updated details. What this does, sends back the view model so the UI can immediately reflect the new customer information. Why it matters, keeps the user experience seamless and confirms that their edits were saved. To summarize, we loaded the correct order entity from the database. We assigned the new address, postal code, phone number, and name from the view model to the entity. We queued and saved the update via our unit of work. We returned the updated view model for immediate feedback. With update order details complete, Order Service now fully supports updating customer information on an order. In the next video, we'll review and polish our service before integrating it into the controller. See you in the next video. Hello. We have completed our service layer, category service, order service, and all related methods. In the upcoming videos, we will create the user service and implement authorization to secure our admin panel. By postponing user service until later, administrators won't need to log in for every action, saving time and making the workflow faster. Now, let's move into our MVC layer. Before we start writing any code, let's scaffold our category controller. Once the controller is in place, we'll write the code together. Great! That's our controller skeleton. Now let's break down each piece. First, we decorate the controller with Area Admin. What this does, it places the controller in the admin area, so its views and routes are scoped under admin. Why it matters: keeps admin functionality separate from the public-facing site. Next, we define the controller class. Public class category controller, controller. Y inherits from ASP.NET Core's base controller, giving us access to MVC features like view. Then, we declare our private fields. A read-only iUnit of work named _UOW. A category service named _category service. What this does, holds references to our data layer through _UOW and business logic through _category service. Why it matters: allows the controller to delegate data operations to services, keeping controller code slim. After that, we write the constructor. ASP.NET Core's dependency injection supplies the required UOW and category service instances. Ensures our controller has what it needs without newing up dependencies manually. Finally, we implement the index action. Calls get all categories on our service to retrieve the full list of categories. Passes that list to the index view, allowing the admin to see and manage categories. To summarize, we set up an admin area controller. We injected our unit of work and category service. We implemented an index action that fetches and displays all categories. With the controller in place, our admin can now navigate to admin category and see the list of categories. In the next video, we'll scaffold the views and wire up create, edit, and delete operations in the controller. See you in the next lesson. Hello everyone. In this video, we'll finish our category controller by adding and explaining the create, edit, and delete actions in order. First, let's write the create method. That's our getCreate method. Now, what does it do? Defines a public action named create with no parameters. Calls view to render the create.cshtml razor view. Why it matters? This displays the empty form to the user so they can input a new category before we handle the post. Now, what did we do here? We decorated it with HTTP post to handle form submissions. We accept a category object from the form. We check model state .is valid to ensure validation passed. If valid, we call _category service .create category to save the new category, then redirect to index. If invalid, we return the same view so the user can fix errors. Next, let's write the edit methods. First, the get version. And now the post version. Awesome, our edit methods are in place. Here's what each part does. Edit get. Accepts an optional ID. Returns not found if ID is missing or invalid. Retrieves the category via _category service .getCategory by ID. If not found, returns not found again. Otherwise, passes the category to the edit view for pre-filled form fields. Edit post. Decorated with HTTP post for form submission. Accepts the updated category object. Validates with model state .is valid. On success, calls _category service .update category and redirects to index. On failure, redisplays the form so the user can correct errors. Finally, let's write the delete method. Nice, that's our delete method. What happens here? We accept a required ID parameter. If ID is invalid, 0 or negative, return not found. call underscore category service dot delete category ID to attempt deletion. If deletion fails, service returns false, return not found. Otherwise, redirect back to index to show the updated list. To summarize, we wrote the create action and explained its flow. We added both edit methods and unpacked their logic. We implemented delete and detailed its validation and redirection. In the next video, we'll scaffold the corresponding Razor views to complete our CRUD interface. See you in the next video. Hello everyone. In this video, we're going to scaffold and build our create.cshtml view for the category entity, focusing on fields and tag helpers rather than CSS or HTML minutiae. First, let's add the view. Right-click on the Create action in Category Controller. Choose Add View. In the dialog, under MVC View, select Razor View Empty. Name it Create and click Add. Before we write our create.cshtml code, there's one important setup step. In underscore view imports .cshtml, we previously commented out the model namespace like this. At asterisk using e-commerce, domain, entities asterisk at. We need to uncomment that line. Using e-commerce, domain, entities. Why? Because Razor views use underscore view imports to know where your model types live. Without this using statement active, at model category in our view won't compile because the category type isn't in scope. Now, let's write the view code. Great, the view is ready. Now let's break down what each part does and why it matters. First, we declare the model at the top. At model category. What it does, tells the Razor engine that this view expects a category object. Why it matters, enables strong typed tag helpers so asked for equals name knows to bind to category.name. Next, we open a form that posts back to the same action. Form method equals post. What it does, sets up an HTTP post form submission. Why it matters, ensures our create action will receive the form data. Then, we render the input field for the name property. Label AS4 equals name. The label helper automatically generates a label linked to the input. Input AS4 equals name class equals form control. The input helper generates input whose name and ID match the name property. Why it matters, tag helpers handle naming, error display, and model binding seamlessly. After that, we add our buttons row. A save button of type submit, styled with Bootstrap's btn primary. And a back to main link using AskController equals category and AskAction equals index. What it does: Save submits the form to create a new category. Back to main navigates back to the category list without posting. Why it matters: Tag helpers generate the correct URL for the link and maintain clean, readable markup. To summarize, we created a minimal Razor view named Create. We bound it to the category model. We used ASP4 tag helpers for our name field to ensure proper model binding and validation. We added a submit button and a navigation link powered by tag helpers. With this Create view in place, administrators can now add new categories through a straightforward form. In the next video, we'll implement the edit and delete views to complete our CRUD interface. See you then. Hello everyone. In this video, we're going to scaffold and build our index.cshtml view for the category list. We'll focus on how to render a table of categories using Razor tag helpers rather than diving into CSS or HTML minutiae. First, let's add the view. Right-click on the index action in Category Controller. Choose Add View. In the dialog, under MVC View, select Razor View Empty. Name it Index and click Add. Now, let's write the view code. Great, the view is ready. Now let's break down what each part does. First, we declare the model at the top. At model IEnumerable of category. It tells Razor that this view expects a collection of category objects. So it enables us to loop over model and render each category in the table. The IndLT, and GT, tag helper generates a link to the create action. It provides a clear page heading and a button to add a new category. Then, we render the table structure. Table classes apply bootstrap styling. The for each loop iterates over each category in model. At category, name displays the category's name. Two link tag helpers generate edit and delete buttons, each passing the ID as a root parameter, and delivers a dynamic, data-driven table where each row maps to a category and provides actions for editing or deleting. To summarize, we created an index view bound to an IEnumerable of category. We used AskController, AskAction, and AskRouteID tag helpers to build navigation buttons. We looped through the model with @ForEach to render each category's name and action links. With this index view in place, administrators can see all categories at once and navigate to create, edit, or delete operations. In the next video, we'll implement the edit and delete forms to complete our CRUD interface. See you in the next video.
Hello everyone. In this video, we're going to scaffold and build our edit.cshtml view for the category entity. By the end, you'll see how to create a simple edit form with tag helpers, and we'll note why we don't need a separate delete view. In the next video, we'll register category service and our other services in program.cs, then test create, edit, and delete end-to-end. Adding the edit view. In Category Controller, right-click on the Edit Get action. Choose Add View. In the dialog, under MVC View, select Razor View Empty. Name it Edit and click Add. Now, let's write the view code. Great! Our edit form is in place. Now let's break down what each part does. Model declaration. At model category. What it does, binds the view to a single category object. Form tag. Form method equals post AskAction equals edit. Posts the form back to the edit post action in Category Controller. Why it matters, ensures the updated category fields are submitted for processing. Label and input for name. Label asked for equals name. Input asked for equals name class equals form control. What it does. Asked for equals name on the label generates a label tied to the input's ID and name. Asked for equals name on the input generates the corresponding input element with model binding. Why it matters. Tag helpers handle naming, binding, and validation attributes automatically. Buttons row. Button type equals submit class equals btn primary. Text is save button. What it does. Save submits the form to persist changes. Since we explained the back to main line in the previous video, I will skip this line without repeating it. To summarize, we created an edit view bound to a category model. We used AskFor and AskAction tag helpers to wire up the form fields and post back to our controller. We added save and back buttons for smooth user experience. Since deletion is handled directly from the index view's delete link, we don't need a separate delete view. In our next video, we'll register category service and other services in program.cs and then walk through testing our create, edit, and delete flows in the browser. See you in the next video. Hello everyone. In this final part, we'll wire up our services in program.cs, then run the app and test the full create, edit, and delete flows in the browser. Firstly, register services in program.cs. For that, now open program.cs and locate your builder. Services setup, then add the following lines. Builder, services.addScoped, category service, builder, services.addScoped, order service, builder, services.addScoped, product service. Nice, that's our service registration complete. These lines tell ASP.NET Core's DI container to provide instances of our services whenever controllers or other components need them. Next, run the application and test create. Start the app, press F5 or run.NET Run. In your browser, navigate to admin, a category, a create. In the name field, enter novel book. Click Save. You'll see the form submits, and you're automatically redirected back to the index page. OK, next we verify the new category on index. On the category list page, you should now see novel book listed. Now time to test edit flow. Click the edit button next to novel book. Notice the URL has changed to the admin a category, the editor 1. That 1 is the ID of our new category. The name input is already pre-filled with novel book. Change it to historical novel and click Save. You'll be redirected back to index, and you'll see the updated name historical novel immediately. Now we are demonstrate back to main button. Click Edit again. On the edit form, click back to main instead of save. You're taken straight back to index without making any changes, no post to close. And last action, test delete flow. On the category list, click the delete button next to historical novel. The row disappears instantly, confirming the deletion without needing a separate confirmation view. Finally, click Add New Category once more, enter Sci-Fi Adventure, and click Save. You're redirected to index, and Sci-Fi Adventure appears in the list. To summarize, we registered our services in program.cs. We demonstrated creating novel book, editing it to historical novel, and deleting it. We showed how back to main skips form submission. We ended by creating Sci-Fi Adventure. With these flows working end-to-end, our category management is fully functional. In our next video, we'll move on to building the product controller, setting up its actions and views so you can manage products, just like we did with categories. See you in the next lesson. Hello everyone. We already walked through those category controller details in the previous video, so we'll skip that repetition here. Let's add our product controller and write the code together. Our code is ready. Let's break it down and talk about what it all means. First, notice the area, admin, attribute which places this controller in the admin area. So our URLs will be admin a product. Next, the constructor inject product service underscore product service encapsulates our business logic and data operations. Then, the index action fetches all products via the service and sends them to the list view. The upsert get action retrieves a product VM for either creating a new product or editing an existing one. After that, the upsert post action validates the model. If invalid, it reloads the same view model and returns the form. If valid, it calls upsert product, passing both the view model and the uploaded file to handle create, edit, and image uploads in a single method. Finally, the delete action checks for valid ID, calls the service's delete method to remove both the product and its image, then redirects back to the index. That wraps up the product controller setup. In the next video, we'll scaffold the upsert view, complete with image preview and category dropdown, to finish our product management UI. See you then.
Hello. Since the code here is a bit more complex than in the category view, we'll build our upsert.cshtml using a description, code, explanation flow. That means we'll first give a brief description, then show the code snippet, and immediately follow with what it does. First, let's add the view. Right-click on the upsert action in Product Controller. Choose Add View. In the dialog, under MVC View, select Razor View Empty. Name it Upsert and click Add. Firstly, describe the model we'll use. This tells Razor that our view expects a product VM model. Show a dynamic header for add versus edit. If model.product.id is 0 or less, it displays add, otherwise it shows edit. Begin the form for post and file upload. The multipart, the form data, encoding allows image files to be uploaded from the client. Preserve the product's ID and existing picture path. These hidden fields ensure that the product ID and current picture URL are sent back when the form is submitted. Display the existing image if there is one. If picture isn't null, the current image is shown at 250px width. Add a field for the product name. ASP4 equals product. Name binds both the label and input to the name property in our model. Add basic fields for the product description, product price, product barcode. Add a drop-down for category selection. Here, the asked-for attribute tells Razor to automatically set both the name and ID attributes to match product.categoryID. That way, when the form is submitted, the chosen category value flows straight into the category ID property of our model. The ASP_items attribute takes every entry in model.categoryList and turns it into an HTML option. In other words, each category from our list becomes a selectable line with its own value and display text. By applying the form control class, we get bootstrap styling on our drop-down, full width, comfortable spacing, and a subtle focus highlight. Finally, we include a disabled, selected option that reads "Please select a category." It appears first as a prompt when the page loads, but users can't actually choose it. Its sole purpose is to guide them. What does this give us? The user clearly sees where to select a category and what to choose. Razor tag helpers keep our HTML concise while enabling strong model binding. Bootstrap's form control ensures a clean, modern look that fits seamlessly with the rest of the design. Here we add the image upload field. We start with a raw container that gives it vertical spacing. Inside, we use a label tied to the model's picture property so Razor handles the linkage, then an input of type file that only accepts image files. Next, we place our Submit button. Its text reads Add when the product's ID is 0 or less, and Edit when we're updating an existing product. This gives users a straightforward way to upload or replace a product image and a clear, context-sensitive action button. Summary. Hidden inputs preserve the product's ID and existing picture. We conditionally displayed the current image. Each field was bound to our product VM model with ASP4. We supported file uploads via multipart the form data. The Submit button text dynamically shows Add or Edit. In the next video, we'll create the index.cshtml view to list all products, complete with edit and delete links. See you in the next video. Hello. In this video, we'll walk through creating our index.cshtml view. As you've already seen in the category and order views, we just right-click the index action and select Add View. I'll skip over those basics since you know them well. Our index.cshtml uses the same structure as before. The only addition is a small thumbnail for each product row. Inside the for each loop, we added. This line pulls the image URL from product, picture in the model and displays it at 80 pixels wide. Everything else, table headers, the Add New Product button, row generation, and the Edit Delete links, works exactly as in our previous category index and product upsert views. Model declaration and container layout, header and Add New Product button, table and header cells, row generation via for each, edit and delete links on each row. With this small change, our product list now shows name, price, and a helpful visual preview. In the next video, we'll test the view to ensure images load and display correctly. See you then. Hello. In this section, we'll test the product management flows we just built, adding, editing, and deleting products right in the browser. Let's go step by step. First, start your application by pressing F5 in Visual Studio or clicking the green play button. Once it's running, you'll land on the home URL. Next, in the address bar type admin the product and press enter. Because our routing defaults to index when no action is specified, admin the product takes us straight to the product index page. Since we haven't added any products yet, the list is empty. Now click the blue Add New Product button at the top. This brings you to our upsert form, which handles both create and edit operations. Let's fill out the form. Enter Galactic Explorer in the name field. Type a brief description in the description box. Put 49.99 into price. Fill GE001 in the barcode. Open the category drop-down and select Sci-Fi Adventure, our previously created category. Finally, click Choose File, pick an image. With everything in place, click Add. Oops! Nothing happened. We got redirected back to the upsert form instead of index. That occurred because our code still contains this validation check in the controller. Any missing or invalid field forces us back to the form. In our case, repopulating the view model here is redundant. Our service's own logic already handles whether it's a new or existing product. Removing this entire if model state dot is valid block lets the upsert product method run unimpeded. Since the service checks product ID less than or equal to 0 to decide create versus update. Let's fix that now. Remove the model state check and the extra getProduct VM. Return view VM lines from the post action. Now, rerun the project from scratch and navigate to add new product again. Let's fill out the form. Enter Galactic Explorer in the name field. Type a brief description in the description box. Put 49.99 into price. Fill GE001 in the barcode. Open the category drop-down. Select Sci-Fi Adventure, our previously created category. Finally, click Choose File, pick an image, and click Add. When we click Add New Product again, we now hit a null reference exception because _www root path is still null. Our product service isn't receiving iWeb host environment. Let's update the product service constructor like this. Here, iWeb host environment gives us the application's root folder root, so our image upload and deletion code runs against the correct disk directory. Fixing the build error, adding a framework reference. This line pulls in ASP .NET Core's core libraries and services, including iWeb host environment. Save your changes and run the application again. Now, clicking Add New Product, filling in the form, selecting an image, and hitting Add should work without errors. The new product appears on the index page, complete with its name, price, and a thumbnail preview. Yes, the form posts, and you're redirected back to the index page, now showing your new product with its name, price, and a thumbnail preview. Next, let's test editing. Click the Edit button on that product row. You'll see the upsert form again, this time labeled Edit and pre-populated with your values. You return to the index page and see your changes reflected immediately. Finally, let's verify deletion. First, add a second product. Click Add New Product again. And create Star Cruiser with any image. Back on the index, you now have two entries. Click Delete on one of them. The page reloads and the deleted product has disappeared from the list. Congratulations! You've successfully tested creating, updating, and deleting products in our admin interface. In the next video, we'll move on to creating and coding our order controller. See you there.
Hello. In this section, we're going to add our order controller and wire up its actions. Since we've already covered controller setup in the category and product examples, I'll focus on what's new here. First, let's add the controller class. Right-click the areas of Admin a Controllers folder. Choose Add Controller. Select MVC Controller Empty and name it Order Controller. Now, let's write the code. Great, that's our controller in place. Now let's break down the new pieces. First, by injecting order service into the constructor, we gain access to all our order-related operations. Next, the index action simply calls getAll and passes its result to the view. This displays a list of active orders. Then, the details action takes an ID parameter, calls the details method on our service, and returns a detailed view model for that order. Finally, we have 3 HTTP post actions: delivered, cancel order, and update order details. Each one receives the current order VM, calls the corresponding service method to update the order status or details, redirects back to the details action for the same order so the user sees the updated information. By keeping our controller thin and pushing business logic into order service, we maintain clean separation of concerns. That wraps up our order controller setup. In the next video, we'll scaffold the index and details views and wire up the buttons and forms to these actions. See you in the next video.
In this video, we'll walk through how to create views for the methods in our order controller step by step. First, scaffolding a view. In Visual Studio, right-click on the index action method in the order controller and choose Add View. This automatically creates an order folder under Area's admin views with an index.cshtml file inside. From here on, we'll concentrate on Razor's programming features, model binding, form posts, and other dynamic behaviors, rather than static HTML markup. Now, importing pre-built view files. First, extract the contents of the ZIP. For example, right-click on order.zip and choose Extract to Order if you're using WinRAR. Then drag and drop the extracted .cshtml files into the Areas for Admin for Views order folder. They'll appear under Areas for Admin or Views for Order in your project. Next up, in the next video, I'll walk through important or previously unmentioned parts of these view files and explain how they work. Hello and welcome. Today we're going to explore the dynamic heart of our order controller views. No HTML or CSS deep dives, just the powerful Razor programming features that make them work. First, let's look at index.cshtml. At the very top we declare our model. This view expects an IEnumerable order product. That tells Razor, give me a list of orders. Then, with a simple @for each, we loop over each order product and output a table row. We inject @orderProduct.id, @orderProduct, name, @orderProduct.orderPrice, and @orderProduct.orderStatus into their cells. We use ASP.NET Core tag helpers. AspArea equals admin, AskController equals order, AspAction equals details, and AspRouteID equals @orderProduct.id to generate a details link that points to admin order details ID without us ever hard-coding a URL. Notice how clean that is. Data binding, loops, and tag helpers, all in under a dozen lines. Next, in details.cshtml, we switch to our order VM view model. Inside the form, we include input asked for equals orderProduct.id hidden. That hidden field makes sure our post request knows exactly which order we're editing. We also add a back to orders link. Our AspAction equals index class equals btn secondary back to orders OA. Again, no hard-coded paths. AspAction equals index does the heavy lifting. Finally, let's look at the two bits of Razor logic side by side. These conditionals decide which action buttons to show based on the order's current status. Mark as delivered button. When it appears, only if order status is exactly ordered. What it does, renders a primary button labeled delivered order. Clicking it will post back to your delivered action, so you can update that order's status to delivered. Why this matters? You don't want a delivered button showing up once an order is already delivered or cancelled. That would be confusing or even break your logic. Cancel order button. When it appears, only if order status is neither cancel nor delivered. What it does, renders a danger style button labeled cancel order. When clicked, it posts to your cancel order action, changing its status to cancel. Why this matters? You prevent cancelling an order that's already delivered or already cancelled, both of which should be final states. Together, these two active blocks ensure. Ordered shows both delivered order and cancel order buttons, giving you the choice. Delivered shows no buttons, since you can't change a delivered order. Cancelled shows no buttons, since it's already cancelled. Any other intermediate status. Processing shows only cancel order, because you can cancel, but not yet deliver until it's fully ordered. By encapsulating this logic in Razor, you keep your view smart and your users in only valid flows, no extra UI clutter, and no invalid transitions. Hello. In this video, we'll begin by creating our register view model and then our login view model, examining the purpose of each property step by step. But before that, let's remove the automatically generated identity folder under e-commerce, web areas. By deleting it, we'll use our own Razor views instead of the scaffolded Razor pages, keeping our MVC workflow clean and consistent. First, open the View Models folder in the application layer and add two new classes in order, Register View Model and then Login View Model. This sets up the shapes of our forms, what fields they'll include, how they'll appear, and which validation rules apply. On to the code. We add the necessary code for Register View Model. Next, we complete the code for Login View Model. With the code in place, let's dive into what each part does. First, let's start with the Register View Model explanations. Email. The required and email address attributes ensure this field cannot be empty and must follow a valid email format. If the user enters an invalid address, form validation will catch it. Password. Required prevents empty submissions. Data type. Password renders it as a password input in the form. String length with a minimum of 6 and maximum of 100 characters stops overly short or long passwords. Confirm password. Data type. Password again produces a password input. Compare. Password forces this value to match the password field exactly, otherwise validation fails. Full name. Required makes sure we always collect the user's full name. Address, postal code, cell phone. These 3 fields are optional. The user can provide them or leave them blank without triggering validation errors. Now let's continue with the login view model explanations. Email. Just like in registration, required an email address enforce non-empty, valid format emails. Password. Required means it cannot be empty, and data type, password renders it as a hidden input. Remember me. A boolean that lets users tick remember me. If true at login, we can extend the session or issue a persistent cookie. That's it. We've added our register view model and login view model classes and explained each property's role. In the next video, we'll create our user service in the application layer and walk through some brief code implementations. See you then. Hello everyone. In this video, we'll make our previously empty user service class in the application layer's admin services folder functional. First, we'll write the core dependency and constructor inside user service, then explain step by step what each line does. Alright, let's start writing our code. Public class user service. Here we define a class named user service. This class will hold the business logic related to users. Private read-only iApplication user repository _ user repository. Inside, we declare a private read-only field of type iApplication user repository. This field will store the repository instance we use to access user data. Public user service, iApplication user repository. We define our constructor, which expects an iApplication user repository instance from outside. This is where we get our repository dependency via dependency injection. User repository equals user repository. Inside the constructor body, we assign the incoming user repository parameter to our user repository field. This way, all other methods in the class can use user repository to perform data access operations. That's it. Our user service class now has the basic setup, ready to receive its repository via injection. In the next step, we'll create an identity area in the e-commerce web layer to handle user operations. We'll set up the necessary folders and files, add the account controller, and in upcoming videos we'll implement the login, register, and other account-related features inside account controller. See you next time. Hello. In this video, we'll add our register async method inside user service and examine what each line does step by step. In the next video, we'll write the methods needed for login. Okay, Let's start writing our code. Alright, we've written our code. Now let's look at what each part does. First, we declare a private, read-only field of type userManager of application user. Then, we inject that userManager into our service via the constructor and store it in a private read-only field. This gives our user service access to the ASP .NET Core identity methods like createAsync and add-to-role-async, which we'll use in registerAsync. Then, we see the method signature. Public async task of identity result register async register view model. This indicates the method runs asynchronously, returns an identity result, and takes a register view model parameter. Next, we create a new application user and assign the user's username and email to model.email, their full name, address, postal code, and cell phone to the corresponding model fields. Then, to add the user to the database, we use await userManager .create async parent user, model .password parent. This triggers the userManager .create async user model password call, saving the user and password via the identity framework. If the result fails, we immediately return that failure. After that, to assign the customer role, we use await userManager add to role async parent user, customer parent. This adds the customer role to our newly created user. If role assignment fails, we package and return those errors. Finally, if all steps succeed, we return the result indicating success. This way, registerAsync handles both user creation and automatic role assignment in a single workflow. In our next video, we'll add and explain the login methods step by step. See you there. In this video, we're going to add login and logout functionality to our user service class. First, we'll inject the sign-in manager, then write the login async and logout async methods, and finally explain why we can drop our old _user repository dependency. Field definition and constructor update. At the top of the class, add this field. Private read-only sign-in manager of application user named _sign-in manager. Then we update our constructor. Here we take in the sign-in manager parameter and assign it to our _sign-in manager field, giving us access to sign in or out methods. Now, write the login async method. Here, password sign-in async tries to sign in with the provided email, password, and remember me option. The final false disables account lockout. And now, write the logout async method for signing out. Sign out async clears all identity cookies and ends the session. Lastly, removing _user repository dependency. Since we now handle login, a logout via _user manager and _sign-in manager, we no longer need. You can safely remove that field and the user repository parameter from the constructor. Summary. Injected sign-in manager to add login or logout. Login async handles sign-in, logout async handles sign-out. Dropped the old repository dependency in favor of built-in identity services. In the next video, I'll show how to call these methods from the account controller and fit them into the MVC flow. See you then. Hello! In this video, we'll be creating a new identity area within the e-commerce web project. This area will allow us to organize authentication and authorization processes in a separate structure. This will make our project more modular and easier to manage. Let's walk through the steps together. First, we right-click on the web layer of our project in Visual Studio, choose Add Area and enter the name Identity. This action creates a new folder structure under areas of identity, including subfolders like controllers, data, models, and views. Next, to ensure our Razor View engine works properly in this area, we need to copy some configuration files. We go to the Views folder under the admin layer and copy the _view imports .cshtml and _viewstart .cshtml files into areas of identity views. These files are essential for our views to recognize necessary dependencies. Now let's explain what we need to do. Since we're working with a layered architecture, specifically the Onion architecture, we won't be needing the default models and data folders inside the identity area. These folders come with the default identity setup, but we manage our models and data access in separate layers. So we select both folders by holding down the Control key and delete them. Let's move on to coding. Inside the Controllers folder under the Identity area, we add a new controller class and name it Account Controller. This controller will serve as the foundation for handling user registration, login, and logout operations in upcoming videos. Now that we've completed our coding, let's summarize what we've done. This controller will act as the central component for all identity-related operations. In this video, we created an identity area in the e-commerce web project, copied the necessary view configuration files, removed unused folders, and created an account controller. In the next video, we will write the register, login, and logout methods. See you in the next lesson. Hello! In this video, we'll be implementing the methods inside the account controller for user registration, login, and logout operations. These methods will form the foundation for our user authentication system. Let's jump into the code. We'll begin by creating the register method. The get version will display the registration form to the user. This method is responsible for rendering an empty registration form in the browser. Now let's write the post version, which will handle the submitted form data. This method first checks whether the submitted model is valid. If not, the same form is displayed again. If it's valid, it calls the _user_service.registerAsync method. If registration is successful, the user is redirected to the home page. Otherwise, the error messages are shown. Now let's define the login method, starting with the get version. This method displays the login form to the user. Next, we define the post version. Here again, we validate the model. If login is successful, the user is redirected to the customer area's home page. If login fails, a general error message is displayed. Lastly, we implement the logout method. This method signs the user out of the system and redirects them to the main home page. Now that we've completed our coding, let's briefly wrap up. In this video, we implemented the core methods inside Account Controller for user registration, login, and logout. In the next video, we'll move on to creating the view files for the register and login pages and begin designing their user interfaces. See you in the next lesson. In this video, we'll be creating the view for the register method we previously added to the account controller. This will allow users to register through a visual form interface. Let's walk through the steps together. First, go to Account Controller. Then just right-click the register action and select Add View. And name the file register.cshtml. Inside the empty view, we'll build the form that collects user information. Let's move on to the coding part. Now that we've finished coding, let's explain what we've done. Firstly, form line defines the target for the form submission. It will send the form data via a POST request to the register method in Account Controller under the Identity area. The class equals row attribute is a bootstrap class used to align form elements in a row layout. The hidden input line is used to remember the page the user was trying to access before registration, so they can be redirected there after signing up. Ask validation summary equals model only collects and displays model validation errors in a summarized format. This helps users see any general issues with the submitted data. We are using tag helpers like asked_for, label asked_for, and span asked validation for. These are Razor features in ASP.NET Core. Asked_for binds the input to a model property. Label asked_for generates a label for the corresponding property. Span asked validation for displays validation errors related to that specific property. We only need to explain this once, as the same structure repeats for each field. Finally, at the bottom, we include a script section. This loads the necessary JavaScript files to enable client-side validation in the browser. In order for this form to function properly, we need to ensure that the user service is registered in our dependency injection container. So let's go to program.cs and add the following line. This registers user service as a scope dependency, meaning a new instance is created per request. It ensures that the service can be injected into the controller without any issues. In this video, we created the view for the register method, explained each part of the HTML and tag helpers, and registered the necessary service in program.cs for the form to work properly. In the next video, we'll run the registration page in the browser, test its functionality, and address any potential errors that may arise. See you in the next lesson. Hello friends! In this video, we're going to run our register page in the browser for the first time and test the process. During this step, we'll encounter a runtime error and we'll walk through how to identify and fix it together. Let's go ahead and run our application. Once we run the application, we are greeted with the following error: system.aggregate exception. Some services are not able to be constructed. As you can see, we are facing a dependency resolution error. So what does this mean? It means that our system is trying to inject a user manager of application user into user service, but it can't find a configured service to provide it. This happens when the identity system is either missing or not properly registered in our application. We'll likely run into several similar errors throughout this process. So let's take this as our first example and work through the solution step by step. Let's head over to Program CS and update the identity configuration to ensure everything is correctly wired. You might currently have the following default line. We're going to replace it with a more advanced setup. Now let's explain why we made this change. The method addDefaultIdentity is great for small-scale apps with basic needs. However, our application requires more flexibility. We'll be managing roles, using email confirmation tokens, and customizing user handling. For this reason, we switched to addIdentity, which supports more extensive features. We also call addDefaultToken providers, so that features like email confirmation and password reset work out of the box. Now let's check our application's request pipeline. We find the line App Use Authorization and add the following line just before it. Why is this important? Because authentication must happen before authorization. Use authentication tells ASP.NET Core to process identity cookies and tokens so it can recognize who the user is. Without this line, even if a user logs in, the system won't know it, and protected areas won't function properly. In this video, we ran our registration page for the first time, encountered a common error, and resolved it step by step. We updated our program .cs to properly configure the identity system and ensured that authentication middleware was added in the correct place. In the next video, we'll dive deeper into identity by working with session and cookie management to maintain user state across requests. See you in the next lesson. In this video, we will configure session management and application cookie settings in our ASP.NET Core project. These settings are essential for managing user sessions and ensuring proper authentication behavior. Let's move on to the implementation. We begin by opening the program.cs file and adding the following configurations to the Builder Services section. This line enables temporary in-memory storage, which is required for session data to function. This block sets up the session configuration. Idle timeout equals timespan dot from minutes 120 sets the session timeouts to 120 minutes of inactivity. Cookie.http only equals true ensures the session cookie is accessible only by the server, enhancing security. This configuration defines authentication cookie behavior. Login path, the path where unauthenticated users are redirected. Logout path, the path used after logging out. Access denied path, the path shown when access is denied due to insufficient permissions. After defining these services, we add the session middleware to the pipeline. It should be placed before app use authentication and app use authorization. This enables session support for handling session data in HTTP requests. Next, we remove the following line from program.cs. This line is specific to Razor Pages routing. Since we are using the MVC architecture and routing with map controller route, this line is no longer needed. Removing it avoids unnecessary configuration and potential routing conflicts. In this video, we configured session and cookie settings, explained each line, and removed the Razor Pages mapping for a clean MVC structure. In the next video, we will continue with session and cookie-based user management examples and perform session behavior tests. See you in the next lesson. Hello. In this video, we will complete the final steps necessary to ensure our project runs smoothly. We've made many configurations so far. Now, let's try to run the project and observe what happens. When we attempt to run the application, we are still encountering errors. Let's now analyze the cause and apply the necessary fixes. First, let's look at the identity configuration in program.cs. Here, the default identity user class is being used. However, we previously created a custom class named application user, which inherits from identity user and includes additional properties. To ensure a complete user structure that supports custom fields, we should update our identity registration as follows. This change allows the system to work with the application user class instead of the default identity user. After switching to application user, all existing references to identity user in the project should also be updated accordingly. For example, in the login partial.cshtml file, we may find the following lines. We update them as follows. This ensures that identity managers are now using the application user type across the application. While in this file, there's one more important update to make. Previously, we removed Razor Pages routing to focus solely on MVC. However, some default links may still use Razor Pages tag helpers like this. Since we're no longer using Razor Pages, such references should be replaced with MVC tag helpers. Failing to make this change will result in broken links and navigation errors. Updating these links is essential for consistent and error-free navigation. In this video, we completed the final adjustments needed for our project to run correctly. We switched to Application User, updated relevant references, and replaced Razor Pages tag helpers with MVC-compatible ones. In the next video, we will test the application and observe how user actions behave. See you in the next lesson. Hello. In this video, we will test that our register page is now up and running properly. However, we can anticipate that an error will occur during the registration process due to some missing configurations in the system. Let's run our project and try to register a new user to observe the outcome. We navigate to the register page, fill out the form fields, and click the Register button. As you can see, an error occurs during the registration process. So, what is causing this error? As you may remember, inside the register async method of the user service, the system automatically assigns the customer role to each new user. However, at this point, there are no roles such as customer or admin defined in the system. Since we're trying to assign a role that does not exist in the database, the operation fails. To solve this issue, we will create a seed data structure that automatically adds the required roles to the system when the application first starts. Let's proceed with the code. This class defines three main roles: admin, customer, and editor. If these roles are not already present in the system, they will be automatically created using Role Manager. Defining the class alone is not enough. We also need to ensure that this seed process runs when the application starts. For that, we add the following block before app run in the program.cs file. This code triggers the seedData.initializeAsync method during application startup and creates the necessary roles if they are missing. Now, since we are about to create the first user in the system, we want to assign them the admin role. To do this, we temporarily change the role name in the Add to Role async line inside the user service from customer to admin. This will ensure that the first user is created with admin privileges. Now we run the project again. Go to the register page, fill in the form fields, and complete the registration. As you can see, this time the registration is completed successfully without any errors. However, since our login page is not yet ready, we won't be able to log in. We will handle this in the next video. Before ending this video, let's revert the temporary admin role assignment in the Add to Role async method back to customer. This ensures that future registrations correctly assign the default customer role. In this video, we analyzed the error encountered during the registration process, used the seed data structure to ensure missing roles are automatically created, and successfully registered a user with admin privileges. In the next video, we will create the login page and implement the user login process. See you in the next lesson. Hello. In this video, we will create our login screen, which is the user login interface. Then, we will log in using the user account we created earlier and test the logout process to complete the authentication flow. Now let's start by creating the login view step by step. First, we right-click on the login method in the account controller and select Add View. In the opened window, we type login in the view name field and create our view file. Now let's add our code to this view file. The structure here is largely similar to the view file on the register page. Therefore, we will not repeat explanations of elements such as form, ask for, ask validation for, label, ask controller, ask action. However, as a difference, the model type on this page is at model login view model. This means the view works with the login view model class and receives form data from it. Additionally, this page includes a Remember Me option for the user. This field is linked to a bool Remember Me property defined in the login view model. Now let's try to log in using the user account we created in the previous video. We fill out the form and click the Login button. As you can see, although we enter the correct username and password, we still receive the message, invalid username or password. What's causing this issue? The reason is the identity configuration in our program.cs file, specifically this line. This configuration is commonly referred to as the identity setup. Here, the line options.signin.requireConfirmedAccount equals true means that users must confirm their accounts, usually via email, before they can log in. Since we have not implemented a confirmation system yet, the login attempt fails. To fix this and allow login without account confirmation, we update the line as follows. After making this change, we run the project again and go back to the login page. We fill in the credentials and click the Login button once more. As you can see, this time the login is successful and we are redirected to the customer area. Since we don't yet have any pages defined in the customer area, receiving a page not found error is completely normal. Now let's go back in the browser. To log out a signed-in user, we use the logout method. This method is defined directly as a post method in the controller and does not require a view file. The purpose of this method is to terminate the user session and redirect them to the home page. It can be triggered directly without a form-based page. Now we register a new user from the register page. Then we return to the login page with the new user information and sign in again. In this way, we confirm that our authentication system works for multiple users. In this video, we created the login screen, signed in using a previous account, performed the logout operation, and completed another registration and login with a new user. In the next video, we will examine how user data and assigned roles are stored in the database. We will review roles, registered users, and identity structures. See you in the next lesson. In this video, we will examine how user and role data are stored in the database using the ASP.NET Core Identity System. We will review the registered users, defined roles, and how these roles are assigned to users. First, we connect to our database using the connection string defined in the appsettings.json file of our project. For this, we will use SQL Server Management Studio, SSMS. In my project, the name of the database is ASP.NET eCommerce Web. You can connect using the name defined in your own project. After connecting to the database, we expand the Tables folder in the left panel. Here, we will see the tables created automatically by ASP.NET Identity. These structures are generated using the code-first approach. Firstly, we'll check the table storing user information, ASP.NET users. All information related to users is stored in the ASP.NET users table. To view this table, right-click on it and select Edit Top 200 rows. As you can see, all users registered through the register page appear here. A unique GID is assigned to each user in the ID column. Additionally, there is a column named password hash, which stores the user's passwords in a hashed format. This ensures that passwords are not stored as plain text in the database. Now let's look at the roles we defined. Roles are stored in the ASP.NET Roles table. Again, right-click the table and select Edit Top 200 rows. As you may remember, we defined 3 roles via the seedData class, Admin, Customer, and Editor. We can see that these roles have been successfully created in the database. Each role also has a unique GID in the ID column. Lastly, let's look at which users are assigned to which roles by examining the ASP.NET User Roles table. This table contains two columns, User ID and Role ID. These fields allow us to see the assignments between users and roles. This structure uses the primary key values of the ASP.NET users and ASP.NET Roles tables to establish relationships. Now let's open these three tables side by side and examine them. As you may recall, the first user we created was assigned the admin role. In my project, this user was created with the email baradira10@mymail.com. In the ASP.NET User Roles table, we can clearly see that the user ID of this user matches the role ID of the admin role in the ASP.NET Roles table. The second user we created was assigned the customer role. This confirms that our user role assignment system is functioning correctly and that the roles defined via seed data have been successfully reflected in the database. In this video, we examined the user, role, and user role mapping tables generated by the ASP.NET Identity infrastructure. We clearly observed how records, roles, and relationships are stored in the database. In the next video, we will begin preparing the customer service structure within the application layer for handling customer operations. See you in the next lesson. Hello friends! In this video, we will start building the service infrastructure responsible for handling customer-side operations in the application layer of our project. These services will manage the business logic related to customer-facing pages. We'll begin by creating the necessary folder structure and then set up our foundational service classes. We go to the application layer and create a new folder under the Services directory. We name this folder Customer Services. Inside this folder, we now create three class files: Home Service, Cart Service, and Order Service. After creating each class, we update their default access modifiers to public. This allows the services to be accessible from outside layers. First, we open the Home Service class and add the following code block. With this structure, we inject both the IUnit-of-Work interface for data access and the iHTTP context accessor component for HTTP context management into the service. This setup allows us to handle user-specific operations and centralize our database logic. Now we move on to the cart service and order service classes. We copy the structure from home service and paste it into these classes, updating only the constructor names according to the class name. These implementations provide the foundational structure of our service classes and prepare the necessary infrastructure to start developing service methods in future lessons. In this video, we created the Customer Services folder, defined the Home Service, Cart Service, and Order Service classes, and injected the common dependencies iUnit of Work and iHTTP context accessor into each service via constructor injection. In the next video, we will begin writing the implementation details of our service methods, starting with Home Service. See you in the next lesson. Hello. In this video, we will add the GET methods to the Home Service class inside the Customer Services folder. These methods will form the foundation for operations such as listing products and displaying product details on the customer-facing side of our system. First, we write the getAllProducts method, which will retrieve all products. This method retrieves all products from the database using the product repository. A key detail here is the include properties category parameter, which ensures that each product's associated category information is also loaded. In other words, this implements eager loading. The return type is IEnumerable of product, which allows the product list to be easily processed on the view side. Next, we write the getDetails method, which retrieves the details of a specific product. This method prepares the product information that will be displayed when a product detail page is opened. The cart class represents a structure used for shopping cart functionality. Count equals 1 sets the default quantity of the product to be added to the cart as 1. Product ID holds the ID of the relevant product. Product fetches the product from the repository, again including the category data. This setup allows product details to be displayed completely, including the category, on the product detail page. Finally, we define the getUserID method, which retrieves the ID of the currently logged in user. This method extracts the authenticated user's identity from the HTTP context. Among the claims, claim types, .name identifier represents the user's unique ID. This ID is especially important when performing user-specific operations, such as adding items to the cart or placing orders. In this video, we added 3 essential methods to the Home Service class. GetAllProducts retrieves the list of products. GetDetails prepares the product details. GetUserID retrieves the currently logged in user's ID. These methods form the core infrastructure for listing and viewing product details on the customer side. In the next video, we will continue by writing the SaveDetails method inside Home Service, where we will handle cart operations. See you in the next lesson. Hello. In this video, we will implement the SaveDetails method in the Home Service class located inside the Customer Services folder. This method will handle adding products to the user's cart, as well as updating the quantity of items already present in the cart. Now we add the following method to our Home Service class. First, we retrieve the unique user ID of the currently logged in user by calling the GetUserID method. If no user is logged in, we return false and exit the method early. If a user is authenticated, we assign the app user ID property of the incoming cart object to the retrieved user ID. Then, we check whether a cart entry already exists in the database for the same user and product. If no such entry exists, the product hasn't been added to the cart yet, we call add to create a new record. If the product is already in the cart, we increase its count and use the update method to reflect the change. We then call save to persist all changes to the database. Lastly, we calculate the total number of items in the user's cart and store it in the session using the key SessionCartCount. This value is typically used to display the cart item count in the site's header. In this video, we added the SaveDetails method to the Home Service class and explained how to manage cart operations for users. We successfully implemented the logic for adding new items and updating existing ones in the shopping cart. In the next video, we will move on to the Cart Service class and begin writing the methods for that service. See you in the next lesson. In this video, we will write a method in the Cart Service class located under the Customer Services folder. This method, named getCart for user async, will retrieve the shopping cart data for the currently logged in user. Its purpose is to prepare and return the list of cart items and the total order price using a view model structure. Now let's write our method in the Cart Service class. First, we access the identity information of the currently logged in user using the claim's principal user parameter. We extract the user's unique identifier via claim types, name identifier. If the user is not logged in, claim equals null. The method returns null, ensuring that the cart cannot be accessed without authentication. If a user is authenticated, all cart records for that user are retrieved from the cart table using the unit of work. The include properties product option ensures that each cart item is accompanied by its related product information. Then, a cart VM object is created, which includes list cart and order product. List cart, the full list of cart items for the user. Order product, an object that holds the total price and other order-related data. Inside the loop, each cart item's total price is calculated and added to orderProduct.orderPrice. This value is typically displayed as the order summary on the front end. In this video, we wrote the getCart for user async method inside the cart service class, enabling us to retrieve the user's cart contents and calculate the total order value. In the next video, we will continue by implementing the getUserID and getCartViewModel async methods to support this structure. See you in the next lesson. In this video, we will add two new methods to the cart service class located under the Customer Services folder, getUserID and getCartViewModelAsync. These methods will allow us to retrieve the identity of the currently logged in user and return detailed shopping cart data associated with that user, all packaged into a ViewModel structure. First, let's write the getUserID method. This method accesses the authenticated user's identity from the current HTTP request context. Claim types .nameIdentifier represents the unique ID assigned to each user by ASP.NET Identity. This ID will be used in future data filtering and repository queries specific to the user. Now let's write the getCartViewModelAsync method, which returns the full cart details and associated user information. First, we call the getUserID method to retrieve the currently logged in user's user ID. If the user is not authenticated, the method returns null and exits. If a user is logged in, we use the cart repository to fetch all cart records that belong to this user. The include properties product parameter ensures that product details are included with each cart item. We also retrieve the corresponding user information from the app user repository using the same user ID. This gives us access to fields like full name, cell phone, address, and postal code. All this data is organized into a CartVM view model. Here the list cart contains all cart items, and order product holds the user and order-related details. Inside the loop, we calculate the total price for each cart item and increment the order price accordingly. For example, if a user adds 2 products priced at $100 each and 1 product priced at $50, first item 2 times 100 equals $200. Second item 1 times 50 equals $50. Total order price is $250, which will be reflected in the order product. In this video, we added the getUserID and getCartViewModel async methods to the cart service. These methods enable us to retrieve user-specific cart data in a structured and presentable format for the view. In the next video, we will use this view model structure to begin implementing the order creation functionality. See you in the next lesson. In this video, we will add the placeOrderAsync method to the cart service class located under the Customer Services folder. This method will handle the complete checkout process by creating an order and its associated details from the cart items, clearing the user's cart, and updating the session data to reflect the new state. Now let's write the placeOrderAsynchron method in the cart service class. Now that we have completed the code writing, let's move on to its explanations. The method receives a CartVM parameter, which contains the shopping cart and user details. First, we retrieve the currently logged in user's ID using the getUserID method. If the user is not authenticated, the method exits and returns false. Then, We use the unit of work to fetch the user's cart items and their profile data. Then, we create a new order product object. This object includes the order date, user details, app user and app user ID, shipping and contact information, total price of the order, and a default order status set to ordered. This order is saved to the database using the add and save methods. Next, for each item in the cart, an order details object is created and linked to the order. This captures the item quantity and price. Once all order details are added, we call save again to persist the changes. After the order is successfully created, we clear the user's cart using remove range and commit the change with another save call. Finally, we update the session value session cart count to reflect the now empty cart. In this video, we wrote the place order async method to handle the process of converting cart data into an order. We created both the order header and its related details, then cleared the cart and updated session values to complete the checkout flow. This structure ensures the order process is executed fully and correctly. In the next video, we will continue by handling user feedback and redirection after a successful order. See you in the next lesson. Hello! In this video, we will add two essential methods to the cart service class, increase cart item and decrease cart item. These methods allow users to manage the quantity of items in their shopping cart from the UI, enabling a dynamic and interactive cart experience. First, let's write the increase cart item method, which will increment the quantity of a cart item. The method receives a cart ID as a parameter and retrieves the corresponding cart item from the database. If no record is found, it returns false to indicate failure. If the record exists, it increases the count value by 1. Then it updates the cart and saves the changes to the database using update and save. This method is typically triggered when the user clicks the plus button in the cart interface to increase the quantity of an item. Now let's write the decrease cart item method, which will decrease the item quantity or remove the item entirely if the quantity reaches 1. The method retrieves the cart item using the provided cart ID. If the count is greater than 1, it decreases the quantity by 1 and updates the record. If the quantity is 1, the item is removed from the cart entirely. When an item is removed, the session value session cart count is also updated by subtracting 1. Finally, the changes are saved to the database. This method is executed when the user clicks the Decrease button to reduce the item quantity or remove the item. In this video, we added the Increase Cart Item and Decrease Cart Item methods to the Cart Service class. These methods allow users to dynamically manage their cart item quantities. In the next video, we will move on to the Order Service class. We will start by adjusting the class name and then proceed to implement the methods required for displaying user orders. See you in the next lesson. Hello. In this video, we will begin working on the order service located under the Customer Services folder. However, before we start writing any code, we will make a small but important naming adjustment. As you might recall, we also have an order service defined under the Admin Services folder. Having two classes with the same name can lead to confusion, especially when registering services in program.cs. To prevent any ambiguity and to make our architecture clearer, we will rename the Order Service class in Customer Services to Custom Order Service. To do this, right-click the Order Service.cs file and rename it to Custom Order Service.cs. After pressing Enter, a notification will appear asking if we want to update all internal references to Order Service within the namespace to Custom Order Service. We can safely confirm this change, as the two service classes reside in different namespaces and will not conflict. With this renaming completed, we can now begin writing the code inside the Customer Order Service class. Since the service logic here is simpler and shorter compared to others, we will implement all methods in a single video. Let's now add the following code to the Customer Order Service class. Now that we've completed the implementation of our methods, let's move on to explaining the code in detail. We've already discussed the getUserID method in several previous videos, so we won't repeat that here. getUserOrders async method. This method is responsible for retrieving all orders placed by the currently logged-in user. Here's how it works. We first get the user's ID using the getUserID method. If the user is not authenticated, the method returns an empty list. If the user is logged in, we query the order product table and filter the results by AppUserID. This allows users to view only their own orders. Cancel order method. This method allows users to cancel an order, but only if the current status is ordered. Here's what it does. It retrieves the order by ID from the database. If the order status is ordered, it updates the status to cancel. The changes are then saved using Update and Save. This setup enables the user to manage their cancelable orders appropriately. In this video, we renamed the Order Service class to Customer Order Service and added two key methods, getUseOrders async and cancelOrder. With these implementations, we've completed the service-side logic for managing orders on the customer side. In the next video, we will start configuring the controllers within the customer area of the e-commerce web layer. See you in the next lesson. Hello. In this video, we will set up the necessary controllers for the customer area within the e-commerce web layer of our project. These controllers will manage customer-facing pages and functionalities such as product viewing, cart management, and order handling. First, we navigate to the areas the customer a controller's directory and create the following three controller classes: Home Controller, Cart Controller, and Order Controller. We created our controllers. Before we start writing the action methods, let's prepare each controller by defining the necessary fields and constructors to inject the appropriate services. In each controller, we use constructor-based dependency injection to provide access to the relevant service. The private read-only fields make these services accessible within the controller class. In the cart controller, we also declare a cart VM property, which will be used to pass cart data to the views. Each controller is responsible only for the logic relevant to its function. This modularity promotes clean architecture, testability, and maintainability. In this video, we created 3 main controllers for the customer area: home controller, cart controller, and order controller. We also prepared each one by injecting their respective services via constructors. In the next video, we'll begin implementing the actual controller methods, starting with home controller. See you in the next lesson. In this video, we will begin by adding the index action method to the home controller within the customer area of our e-commerce web project. After that, we will create the corresponding view and explain how to render dynamic content on the front end using data from our model. First, let's add the index method to the home controller class. This method is responsible for retrieving and displaying all products from the database. We use the getAllProducts method from the home service class to fetch the list of products. The retrieved list is then passed to the view, enabling dynamic data rendering on the page. Next, let's create the view file. Right-click on the index action method. Select Add View from the menu. Set the view name as index and complete the creation process. After the view file is created, we paste the following HTML code into it to display the list of products dynamically. As a reminder, in our views we focus more on dynamic backend driven structures rather than static design details. The line at model IEnumerable of product tells the view to expect a list of product objects. We use a for each loop to iterate over the product list and display each one. At item, picture, at item, name, and at item, price are used to display the product image, name, and price dynamically. The aspRoot product ID equals at item.id attribute allows us to pass the product ID to the details action via root values when the details button is clicked. In this video, we added the index action method to the home controller, created the associated view, and implemented a dynamic structure to display product listings. We also discussed the dynamic elements used in the view. In the next video, we will continue by adding the details action method and its corresponding view to the home controller. See you in the next lesson. In this video, we will continue working within the home controller class inside the customer area. We will implement the functionality to display detailed information about a product and enable users to add items to their cart. After completing the methods, we'll create the associated view and go through its structure step by step. Let's start writing our code in the home controller class. The get version of the details method retrieves a cart object for the specified product ID using the home service. This object is passed to the view to populate the product details dynamically. The post version processes the form submission when the user clicks Add to Cart. The Authorize attribute is used here to ensure that only authenticated users can perform the post action, meaning they must be logged in to add products to their cart. If an unauthenticated user attempts to access this endpoint, they will automatically be redirected to the login page. The cart object is sent to the Save Details method and saved to the database. If the operation is successful, the user is redirected back to the index page. Now that we have completed the implementation of the details action methods, it's time to create the corresponding view that will render the product's details on the page. Now we right-click on the details action method and select Add View. We name the view details and complete the creation process. Next, we paste the following HTML structure into the newly created view file. Now let's move on to the explanations. @Model Cart declares that the view will work with a cart model. Form elements like ASP4 product ID and ASP4 count bind to model properties. Dynamic values like @model product name @model product price. The form posts back to the same action method when the Add to Cart button is clicked. Users can select the quantity and then add the product to their cart. With that, we've completed everything we needed to do in this lesson. To quickly recap what we've done. In this video, we implemented the get and post versions of the details method in the home controller, created the corresponding view, and configured dynamic content to display product information. In the next video, we will move on to testing our code. We'll begin by registering home service for dependency injection in program.cs and then launch the project to verify the customer page functionality. See you in the next lesson. In this video, we'll take two important steps to finalize our setup. First, we'll explicitly assign the home controller to the customer area using the area attribute, and then we'll register the customer order service in program.cs to make it available for dependency injection. Firstly, as you remember, we created the home controller under the customer area. However, unless we explicitly annotate it with the area attribute, ASP.NET Core might not correctly route requests to this controller. So let's open the home controller class and add the following line right above the class definition. The area customer attribute tells the framework that this controller belongs to the customer area. With this setup, route matching and view rendering will work correctly for this controller. For example, URLs like a customer, a home index will be directed to this controller's index action. Without this attribute, routing might fail or views might not be correctly located and rendered. Now, let's register the customer order service in the service container to enable its usage across the application. Open your program.cs file and add the following line. We use AddScoped to register the service with a scoped lifetime. Without this registration, attempting to inject the service into a controller would result in a runtime error like unable to resolve service. So we have completed what we need to do in this lesson. In conclusion, in this video, we added the area customer attribute to the home controller, enabling proper routing under the customer area. We also registered the customer order service in program.cs, making it available for dependency injection throughout the application. In the next video, we will launch the project, test controller routing, and verify that everything works correctly. See you in the next lesson. In this video, we'll test the functionality of the home controller that we have recently completed. By running the project, we'll verify that the customer area routing is functioning correctly and that both the index and details pages load without any issues. Running the project and accessing the customer area. Let's start by running the project. Once the browser opens, append a customer to the end of the URL to navigate to the customer area. In ASP.NET Core MVC, if no specific controller or action is defined in the root, the application will default to the index action of the home controller. So when we enter a customer in the browser, it will automatically direct us to a customer or home index. As you can see, the index page loads smoothly. All products are displayed successfully. Now, let's click on the Details button for one of the products. We are now on the Details page. At the top, we see the product name in a large header, and to the right, the category of the product is shown. Below that, the product's barcode, price, and description are displayed in a read-only format. Additionally, there is an input field for count where the user can enter the quantity of the products to be added to the cart. At the bottom of the page, there are two buttons. Back to main takes the user back to the index page. Add to cart will eventually allow the products to be added to the cart. Since the cart functionality has not been implemented yet, clicking the Add to Cart button will not perform any action at this stage. Let's now click the Back to Main button and check that it properly redirects us to the index page. And yes, we are successfully redirected back. Conclusion. In this video, we tested the index and details action methods within the home controller, along with their corresponding views. We confirmed that everything is functioning as expected. In the next video, we'll begin developing the functionality inside the cart controller and start implementing cart management features. See you in the next lesson. Hello friends! In this video, we will complete the configuration of the cart controller class, which we previously prepared the infrastructure for. This controller handles all cart-related actions, and will write all the action methods in this single video since most of them are relatively short and straightforward. We'll exclude only the view implementation for the order post method, which we'll cover in the next video. Now, adding area and authorization attributes. Before writing the methods, let's start by defining the area and access control attributes at the top of our controller. Area customer specifies that this controller belongs to the customer area. Authorized ensures that only authenticated users can access this controller. If a user is not logged in, they'll be automatically redirected to the login page. Let's start writing our methods in Cart Controller. First, we'll implement the index action method. This method retrieves the current user's cart data using the getCartForUserAsync method. If the user is not logged in, it returns null and redirects them to the login page. If authenticated, the cart data is sent to the view. Next, let's move on to the orderGetAction method. This method loads a detailed view of the user's cart before placing an order. If the user is not authenticated, they are redirected to the login page. Now let's write the post version of the order method to handle the order process. This method is triggered when the user submits the order form. It uses the placeOrderAsync method to finalize the order. The validateAntiforgery token attribute protects the form from CSRF attacks. Upon success, the user is redirected to the home controller's index action in the customer area. Now let's implement the increaseAction method. This method increases the quantity of a specific product in the cart by 1. After updating, the user is redirected back to the cart view. Let's finish with the decreaseAction method. This method decreases the product quantity by 1. If the quantity reaches 1, the product is removed from the cart entirely. The user is redirected back to the updated cart view. Conclusion. In this video, we implemented all core action methods within the cart controller and explained the purpose of each in detail. With this structure, users can view their cart, adjust product quantities, and initiate the order process. In the next video, we'll begin building the view files for these methods and start designing the cart page dynamically. See you in the next lesson. In this video, we'll create the view file associated with the indexAction method of the cart controller. This view will allow the user to see the products in their cart, update quantities, and view a summary of the total price before proceeding to checkout. We will also walk through all the dynamic parts of the view in detail, including the use of model bindings and tag helpers. Now, let's create the view file. First, right-click on the index action method in Cart Controller and from the context menu, select Add View. Leave the view name as index and complete the process. Let's add the view code. Once the view file is created, paste the following HTML and Razor code inside. Let's move on to explaining the code in detail. At Model Cart VM. This specifies that the view receives a model of type Cart VM, which contains both the cart items and the order summary. At For each var item in model.listCart. Iterates through each cart item and renders it on the page. At Item, Product, Name at Item, Product, Picture at Item, Count at Item, Price. These are dynamic Razor expressions that display product data from the model. AskAction equals increase, AskAction equals decrease. These tag helpers generate links to the increase and decrease action methods respectively. AskRootCartID equals at item.id. This adds the cart ID value to the root as a parameter, allowing the controller to identify which item to modify. At model.orderProduct.orderPrice.toString 0.00 displays the total amount with 2 decimal places, used in both the cart total and amount to pay fields. AskAction equals order. This tag helper generates a link to the order action where the order confirmation process begins. In conclusion, in this video, we created the index view for the cart controller, added dynamic elements to list cart items, display totals, and integrated navigation controls using tag helpers. Each dynamic component and helper was explained in detail. In the next video, we'll continue by building the view for the order action method and design the order confirmation page. See you in the next lesson. In this video, we're going to test the action methods we previously created in the cart controller. Before we start testing, we need to make sure the cart service is registered in the dependency injection DI container. Registering cart service in program.cs. Let's navigate to the program.cs file. In the section where services are configured, add the following line. This ensures that cart service is available to be injected wherever needed within the application with a scoped lifetime, 1 instance per request. Starting the application and beginning the test. Now that our service is registered, we can run the project and begin testing. By default, the application opens on the home controller inside the admin area. Therefore, to access the customer area, we need to manually append a customer to the URL. Since both the controller, home controller, and action index are set as defaults, we don't need to explicitly include them in the root. Adding products to the cart. Let's go to the detail page of the product named Misty Night. Set the quantity to 2 and click the Add to Cart button. After submission, we are redirected back to the Home Index page, indicating the product has been added successfully. Now navigate to the detail page of Galactic Explorer. Add 1 unit of this product to the cart. Viewing the cart. To view the cart, manually enter a cart into the browser's URL bar and press Enter. On the cart page, you should see both products listed in separate cards. Each card displaying the product image, name, quantity and total price. On the right, under the order summary card, you'll find the cart total and amount to pay values. Note, at this stage, cart total and amount to pay are the same. In the future, if you want to include discounts or shipping costs, you can calculate and display them in the amount to pay section. Testing increase and decrease buttons. Now let's test adjusting the quantity of products using the plus and minus buttons. Increase the quantity of Galactic Explorer to 3. You'll see the total price for the product and the cart total both update accordingly. Now decrease the quantity back down to 1. When the count is 1, click the decrease button again. At this point, the product should be removed from the cart entirely. Let's verify this behavior. As expected, the product disappears from the cart, confirming that the logic is working properly. Now let's test what happens when a user tries to add the same product again from the product detail page. On the Home Index page, go to the Misty Night product detail page. This time, add 3 more units. Go back to the cart by navigating to a customer cart. If everything is working correctly, you should see 1 card for Misty Night with the updated quantity of 5. This confirms that our system successfully merges multiple editions of the same product. In this video, we tested the functionality of all key action methods in the cart controller. We validated adding products to the cart, increasing and decreasing product quantities, handling removal when quantity reaches 0, combining quantities of duplicate product entries. Everything worked as expected. In the next video, we'll create the order view that enables users to confirm the items in their cart and place an order. In this lesson, we'll create the order view that enables users to confirm the items in their cart and place an order. We will walk through both the creation and the purpose of each element on the page. Creating the view file. First, right-click on the Order Action method inside the cart controller and select Add View. Name the view order and confirm. Let's add the contents of the order.cshtml file we created. This view allows the user to review and confirm the order before submitting it. The user can update shipping information and view the products in the cart with their respective quantities and prices. Let's now go through all the dynamic fields and tag helper usages in this view step by step. At Model Cart VM. This line declares that the view is bound to a Cart VM view model. CartVM.listCart contains the list of cart items. CartVM.orderProduct contains user shipping and order information. Form method equals post. This is a standard HTML form tag. The data entered in this form will be submitted to the server using the post method, specifically to the order post action method of the controller. ASP4 equals order product, name and similar tag helpers. These are ASP.NET Core tag helpers used to bind form fields to the ViewModel properties. Examples: input ASP4 equals order product. Name binds this input field to the name property inside order product. Span ASP validation for equals order product. Name displays a validation message if the input does not meet the defined validation rules. This setup enables automatic model binding and validation support. At for each, var details in model.listCart. This loop dynamically lists each product in the cart. At details, product, name, displays the name of the product. At details, count, displays the quantity ordered. At details, price.toString, C formats the total price per product using currency format, C. At model.orderProduct.orderPrice.toString, C. displays the total order price for all items in the cart. This value is calculated based on the sum of each item's price multiplied by its quantity. This is the submission button that sends the form data to the server. Clicking this button triggers the post request to process the order. In summary, in this view, the form is bound to the cart VM view model. Tag helpers are used to bind inputs directly to model properties and handle validation. The user can confirm shipping information and view a dynamic list of products with quantities and prices. This setup ensures smooth and accurate data flow between the user interface and the back-end logic. As per our instructional focus, we've concentrated on dynamic structures and tag helpers while leaving out static HTML, CSS, or Bootstrap styling details. Now that we've created the view, let's test its functionality. Run the project. By default, the application opens on the home controller of the admin area. To access the customer area, add a customer to the browser's URL. Navigate to a cart to open the cart page. The items we added earlier should be listed here. On the right-hand side, under the order summary card, click the Confirm button. This takes us to the Order Actions view. On this page, users can review and, if necessary, update their shipping details, for instance, sending the package to their workplace or as a gift to someone else. Once the information is reviewed, clicking the Order Confirmation button will complete the ordering process and trigger the order flow. In conclusion, in this video, we built the order view that lets users finalize their cart as an order. We enabled editing of delivery information and dynamically listed the items being ordered. We also verified that the page routes and functions correctly. In the next video, we'll move on to building the order management and tracking features for the customer area, allowing users to view and manage their submitted orders. See you in the next lesson. In this video, we'll complete the final step of our project's architectural setup. That means we'll implement the methods inside the order controller located under the customer area, thereby finalizing the core structure of our application. Before jumping into the code, let's begin by revisiting an important detail we addressed in earlier videos. Since there is also an order service class in the admin layer, we renamed the one used for the customer side to customer order service to avoid confusion. Therefore, within the order controller, we must use customer order service instead of order service. Let's update our service declaration accordingly. With this declaration, we are now correctly referencing the appropriate service for the customer side. We can now proceed to implement the action methods required inside the controller. Let's start with the index action method, which will be used to display the customer's past orders. Here, the _order service .getUserOrders async call retrieves the order history specifically for the currently logged in user and passes it to the view. Next, we'll implement the cancel order method, which allows a customer to cancel an order. This method receives an order ID as a parameter and updates the order's status to cancel if it's currently marked as ordered. Once the operation is complete, the user is redirected back to the order list page. Let's also clarify an important point here. The cancel order action does not require a view file because it performs a direct operation on the data and redirects the user to another page. There is no form or interface involved in this process. To summarize, in this video, we first updated our service dependency to avoid naming confusion between the admin and customer layers. Then, we implemented the two essential methods, index and cancel order, inside the order controller. In the next video, we will create the corresponding index view for this controller and perform our final test checks for the project structure. In this video, we'll complete an important part of the customer order management section in our project. Previously, we implemented the index and cancel order action methods inside the order controller. Now, we'll move forward by creating the index view, writing its code, and then testing the functionality to ensure the system works smoothly. To begin, right-click on the index action method inside the order controller, then select Add View. In the dialog that appears, name the view index and complete the creation process. Next, we'll populate the index.cshtml file with the following code. At model IEnumerable of order product indicates that the view receives a list of order product objects. At ForEach, iterates through each order in the model and displays its data in the table. Tag helpers like askVaria, askController, askAction, and askRouteID automatically generate the correct URL to trigger the cancel order action with the selected order's ID. The onClick attribute adds a client-side confirmation before cancelling an order. For the view to function correctly, a few key configurations must be completed. In the program.cs file, register the service with the following line. This enables the service to be injected and used inside the controller. To define this controller as part of the customer area and to restrict access to authenticated users only, add these attributes to the top of the controller class. Area customer specifies that this controller belongs to the customer area. Authorize ensures only logged-in users can access these methods. Now that we've completed the setup, let's run the application and test everything. In the previous video, I had already added a product to the cart and confirmed the order. If you haven't done this yet, go back and confirm an order from your cart using the Order to Confirm flow. To see the order list, open your browser and navigate to Customer Order. This will load the index page of the order controller in the customer area. You should now see all your orders listed in a table, each with a Cancel button that allows users to cancel pending orders. Conclusion and what's next? In this video, created and coded the index view for order controller, registered the necessary service, applied proper area and authorization attributes, and tested the full flow from order placement to cancellation. In the next video, we'll begin improving the user interface to provide a more polished and user-friendly experience for customers. See you in the next lesson. Hello. In this video, we'll enhance the user experience by configuring our application so that users are directed to the customer area by default instead of the admin area. This change ensures that when the application starts, the customer homepage, where products are listed, is the first thing users see. Updating the default root configuration. Let's go step by step to make this change. Open the program.cs file. Navigate to the section where route mappings are defined. Locate the following default route configuration. As you can see, the default area is currently set to admin, which is why the application opens in the admin area by default. To change the default area to customer, simply replace admin with customer as shown below. With this update, the application will now open directly in the customer area, specifically the home controller's index action. After saving the changes, run your project. When the browser launches, you'll see the customer a home index page loaded by default. This is the page where we previously implemented the product listing functionality. As you can see, it now appears right when the application starts, confirming our setup is working as expected. What's next? In this video, we configured the application to direct users to the customer area homepage by default. In the next video, we'll continue improving the user interface by implementing a navigation menu to make page transitions easier for the user. See you in the next video. Hello. In this video, we'll take another important step to improve user experience. We'll update the navigation menu in the _layout.cshtml file to match the structure of our project. Our goal is to ensure users can easily navigate through key pages such as the home page, cart, and orders. First, go to the e-commerce web project, then navigate to Views then Shared and open the _layout.cshtml file. This file contains the layout structure that applies across your entire application and includes the top menu bar. Inside this file, you'll find the following two menu items already defined. Currently, the first link navigates to the Home Controller's index action, but does not specify an area. Since we want users to start within the customer area, we need to adjust only the askVaria attribute. Change askVaria equals to askVaria equals customer. The rest of the attributes, askController and askAction, already point to the correct locations, so we can leave them as they are. After the change, the link should look like this. Now let's configure a menu item that leads users to their cart page. We can modify the existing privacy link for this purpose. Here's what needs to be updated, step by step. Set askVaria to customer instead of leaving it empty. Change askController from home to cart. The link currently routes to the privacy action. Since we want it to open the cart page instead, which corresponds to the index action of the cart controller, we replace askAction equals privacy with askAction equals index. Update the visible text from privacy to cart. Once all updates are complete, the line should now look like this. Note, if you leave askAction empty, the system will still route to the index action by default. However, we are writing it explicitly here for better readability. Let's also add a navigation item for viewing orders. We can simply copy one of the existing li elements and place it at the end of the list. Then apply the following changes. Update the askController attribute to order. Leave the askAction attribute blank to test the default routing behavior. Change the link text to orders. After completing the updates, save your changes and run the project. When the application loads, the top menu should now display the updated navigation links, home, cart, and orders. Go ahead and click each of them to make sure they route to the correct pages. As you can see, all navigation links work perfectly, providing a smooth user experience across the site. What's next? In this video, we restructured the navigation bar in _layout.cshtml to better reflect our project's structure and user needs. In the next video, we'll continue with more front-end improvements to enhance usability. See you in the next session. Hello. In this video, we'll be giving our admin panel a completely new look by setting up a custom layout. This layout will separate the admin interface visually and make the structure more user-friendly and professional. Let's start by adding the files I previously shared with you into our project. These files are admin.css, which contains styling for the admin UI, adminsite.js, which manages interactive elements like the sidebar, and _adminlayout.cshtml, which defines the structure of the admin pages. You can either drag and drop these into the project or copy and paste them manually. I'll demonstrate using the copy-paste method. First, copy admin CSS.css and paste it into the CSS folder under Woroot in the e-commerce web project. Then do the same for admin site.js, placing it inside the JS folder under Woroot. Next, copy the _admin layout.cshtml file into the views, the shared directory. This file will be used as the base layout for all admin pages. Once we've added all the necessary files to our project, the next step is to make sure our admin pages use the new layout by default. To do that, open the _viewstart.cshtml file. You can find this file by navigating through the folders like this. First go into the Areas folder, then open the Admin folder, and inside that, go into the Views folder. The _viewstart.cshtml file is located right there. When you open this file, you'll find a line that looks like this. This line defines which layout file should be used for all the views under the admin area. By default, it points to _layout.cshtml, which is used throughout the rest of the application, such as the customer area. What we want to do now is update this line so that it uses our new admin layout. To do that, simply replace _layout.cshtml with _admin layout.cshtml. After the change, your line should look like this. Once this change is saved, any views under the admin area will automatically use the new admin layout we created. Now save the file and we're ready to test. Let's run the project. As you know, it normally opens on the customer area, specifically the customer @home index page. But for testing our new layout, we'll navigate to the admin panel. In the browser's address bar, type of admin @home and press enter. And there it is. The admin panel now loads with its dedicated layout. You'll see that the layout, including the header and sidebar, is specific to admin pages. When navigating between pages, the body content updates dynamically, but the layout structure remains consistent. Before we wrap up, there's one important detail I want to highlight. Try logging out from your current session using the Logout button. Then, go back and type admin @home into the browser again. As you'll see, even without being logged in, the admin panel is still accessible. That's a serious security concern. We definitely need to restrict access to the admin area based on roles. In the next video, we'll implement role-based access control so that only authorized users can access the admin panel. This will help us protect the system from unauthorized changes or data manipulation. Let's quickly recap what we accomplished in this video. We added a custom layout for the admin panel. We integrated custom CSS and JavaScript files. We set the new layout as the default for admin views via _viewstart.cshtml. And finally, we tested everything to confirm that it works as expected. See you in the next video. Hello. In this video, we'll be securing our admin panel by ensuring that only users with the admin role can access admin-specific pages. This step is crucial for protecting the system from unauthorized users and maintaining data integrity. Let's begin by adding an authorization attribute to each controller within the admin area. We'll be using the authorize roles equals admin attribute. This tells the application that only users who belong to the admin role should be allowed to access that controller. Start with the category controller. Open the file and locate the area admin attribute at the top of the controller class. Just beneath that line, add the following. This is what enables role-based restriction. Go ahead and repeat this process for all other controllers in the admin area. Place the same attribute just below the area admin line in each file. Once you've added the attribute to all admin controllers, save your changes and run the project. First, log in using an account that has the admin role. Try accessing the admin area. Navigate to admin home in the browser. If everything is set up correctly, the page should load without any issues. This confirms that users with the right role can access the admin interface. Next, log out of the system and try accessing the admin panel again, this time as a non-authenticated user. Enter admin into the URL and hit enter. You'll see that the system redirects you to the login page. That's perfect. It means unauthenticated users are blocked from entering the admin section. Now let's test one more case. Log in with a user who does not have the admin role. Once logged in, try going to any page in the admin area again. This time, instead of accessing the page, you'll be redirected to identity for count access denied. However, since we haven't created this page yet, you may see a message like no web page was found for the web address. At this stage, our role-based protection is working as intended. Only admins can access the admin area. But as you've seen, the access denied page doesn't exist yet. Although the redirect happens correctly, the user lands on a blank or broken page. This creates a less than ideal user experience. In our next video, we'll fix this by creating a proper access denied view that displays a clear and helpful message to the user. In summary, in this video, we added authorize roles equals admin to all admin controllers to enforce role-based access. Tested different access scenarios to confirm that unauthorized users are blocked. Discovered that the access denied page is missing and decided to build it in the next video. See you in the next session. Hello. In this video, we're going to create a custom access denied page that will be displayed when a user without the appropriate permissions tries to access the admin panel. This ensures that instead of seeing a blank or unclear error message, users will be redirected to a meaningful and informative page. Let's get started. First, open the account controller located inside the identity area. This controller contains all the action methods related to user operations. We will now add a new action method named Access Denied to this controller, which will handle the redirection for unauthorized access attempts. Now, write the code. This method tells the system to display a Raise a View page when users are redirected to the identity, the count, and access denied URL due to insufficient permissions. Now let's create the corresponding access denied .cshtml view file for this action. The easiest way to do this is by right-clicking directly on the access denied action method and selecting Add View. From the menu, when the Add View dialog appears, Visual Studio will pre-fill some of the fields. One important thing to note is that in recent versions, the view name is set to index by default. Make sure to manually change it to Access Denied. For the template, select Empty without model. Then click Add to create the view file. Visual Studio will open the newly created view file. In this file, paste the following content. This page clearly informs the user that they don't have permission to access the requested content and provides a button to navigate back to the main page. Now it's time to test our setup. Run your project and log in with a user who does not have the admin role. Then manually enter admin in the browser's address bar to try accessing the admin panel. Since the user lacks sufficient permissions, the system will automatically redirect to an identity, account, or access denied. If everything is configured correctly, the custom access denied page you just created will be displayed without any issues. This step fills an important gap in our application by ensuring users receive clear and friendly feedback when access is denied. See you soon.